Okay.
Okay, well, welcome to the Egeria webinar series. This one is all about how you build an integration connector. Last time we found out about how you to use an integration connector, and we went through all the different types. This time we're talking about how you build an integration connector, and we're going to move on to using and building a repository connector in subsequent months. So I hope you enjoy it. And over to you, Mandy.
Thank you very much. Okay, so in the previous webinar, we went through a number of different scenarios around integration connectors. And I'll just remind you of one of them to get you into the sort of way of thinking in terms of what sort of use cases we have. So in this particular use case, we have a data scientist, which is Callie, and she is working with a database and using it for sandboxes. So she's loading data into these sandboxes and then running experiments on it. And one of the things that she's supposed to do is to create a catalog entry for each of her sandboxes to show what's in it, which she always forgets. And so what the integration connector, the connectors that we're talking about, do is that they sit and monitor a particular resource like a database and then automatically catalog everything that's created in it. So as a new schema of tables, columns are defined for the database, then these are automatically cataloged. So that's the overall scenario. We're looking at the automated cataloging of metadata. And in fact, Egeria has a specialist server for doing this called the integration daemon, which is one of our OMAG servers. So all of our servers that sit on the platform are called OMAG servers, and the integration daemon is a particular type of server. Its sole job is to run integration connectors that may be talking to, each one is talking to different types of technology. So there's a huge range of technology that you can connect through the integration daemon using Egeria. And then all of that metadata is pushed into the open metadata ecosystem. So there's a metadata access server that the integration daemon is communicating with directly. You can think of that as its sort of entry point into the open metadata ecosystem. And then that metadata server is responsible for then distributing it to other members of the cohorts that it belongs to. So from that point, both the metadata that's being extracted by the integration connectors is distributed, but also the integration connectors can issue queries to the open metadata ecosystem and use the results of that in their integrations. Because we're not just interested in bringing metadata into the open metadata ecosystem, we're also interested in pushing it out so that there are consistent definitions, configurations, information being pushed to all the technology that's being used by the organization. So the way to think of the integration daemon is that we're pulling that metadata in and distributing it to the open metadata ecosystem. And we're also querying the open metadata ecosystem or listening to changes to it and then pushing that out to a wide variety of third-party metadata. So given that background, we're going to focus in on the integration connector and how to write your own. The purpose of well, let's start with sort of the overall pieces. So we talked about the fact that we've got the open metadata ecosystem, and we're also talking to some sort of third-party technology. So the focus of the integration connector is one type of technology, and it sits in an integration service that is providing a sort of like a container type environment for that connector. And then the integration service sits in the integration daemon. And the job of these two components, the integration daemon and the integration service, is to take away, is to support all of the common requirements that are required for any piece of integration logic. So it's handling the configuration, the starting and stopping, the providing of a secure environment, restart, threading, management of configuration. So it's doing all of the sort of underlying infrastructure types of information, of function. And then your integration connector, it's just simply responsible for connecting to the third-party technology, connecting to the open metadata ecosystem, and doing the mapping and exchange between those two environments. Now, again, to make it as simple as possible to write an integration connector, there are multiple integration services, and each one is focused on a particular category of technology. So today we have, 10 plus, about 10 integration services, and as I say, they're each focused on a particular type or category of technology. So there's one for integrating with API gateways, and actually to connect to any application that supports the Open API specification. We've got one for analytics tools, one for general data catalogs or metadata catalogs. So this is a very sophisticated exchange for different metadata catalogs. We've got one for databases, one for reporting and sort of form type tools, one for files, if we want to monitor the file system, one for managing infrastructure and sort of configuration files, cataloging from there. The lineage integrator supports the open lineage standard, as well as providing the ability to extract lineage from different types of technology. The organization integrator is around managing information about people, organization structures, teams. Security is about exchanging metadata with access control, enforcement points, so things like Apache Ranger. The stewardship integrator is for exchanging metadata with stewardship tools and human task managers. And the topic integrator is for talking to event brokers such as Kafka. So the reason we have these different integration services is because it's down to the metadata API that these services offer. So each one is specialized. So for example, in the database integrator, there are methods for creating databases, tables, columns. In the files one, you're obviously creating files. In the infrastructure one, you're creating servers and platforms. So they're designed to be specialized for the type of metadata that these categories of technology use, so that your job of creating the integration connector is as easy as possible. So here we have a picture of the sort of internals of the integration daemon. So here you see an integration service, and there could be multiple, they could all be running all the different integration services, and within them multiple integration connectors could be running. There are different patterns that are supported. So you might have a connector that is going to call the technology, I don't know, every hour, and determine if anything's changed and bring that metadata in. We call that a polling connector. We might have one that's going to listen, excuse me, for changes from a third-party technology. So, for example, it might be listening to a Kafka topic or some other type of notification mechanism, and from those events make changes to open metadata ecosystem. Or we might have something that's listening for changes in the open metadata ecosystem and is publishing it out to the third-party technology. So when we're working with Ranger, we're listening for changes to the security tags, for example, and we would be pushing out updates to Apache Ranger's security configuration, and Apache Ranger would then go on and enforce the access control based on the information that Egeria has supplied. So we can go, we can pull things in on a polling basis, on a listening basis, and we can push things out based on changes in open metadata. And as I said before, what's going on behind the scenes, why you're using the integration connector mechanism is that so much of the infrastructure is handled for you from configuration, starting and stopping, restarting, managing threads, and also that polling mechanism is handled for you. All of the code required to connect to the open metadata ecosystem is covered. There are access to Egeria's audit log and the ability to store metrics, as well as the management of what we call metadata provenance. And I will go into that in a little bit more detail. So that's really the environment. So we're thinking about building that blue component there that is just literally focused on the exchange of metadata and the interaction with the third-party technology. I'll pause a second just in case anybody has any questions. Otherwise, I'm going to keep going. So the next thing to notice is that in the metadata access service, so this is the server that's responsible for for storing and managing the metadata in the open metadata ecosystem. The interface that is being used by the integration daemon and the integration service is an OMAS. So that's an open metadata access service. This particular service is using federated queries in order to retrieve metadata from all of the connected metadata repositories in the cohort. Also, when metadata is stored, it may be stored in the local repository, or depending on the type of metadata and the capabilities of the local repository, it may be stored in another server in the cohort. So this OMAS service is sitting on top of the whole cohort. So it's sitting on the whole, it has access to the whole of the open metadata ecosystem. The OMASs, again, are specialized for different categories of technology. So they have different REST APIs and support different event mechanisms. A lot of them support out topics. I'm not sure any support the in topics, although they're architecturally able to do that. But when on the events that they produce on their out topic are, again, specialized events for the particular category of technology. And then they provide a Java client for use in Java applications. Obviously, the integration daemon is running on the OMAG server platform, so it is a Java application, so the client sits there. And then we have a specialist wrapper called the context that is delegating down onto the OMAS client, and that context is supplied by the integration service. So each integration service implements a context and a context manager, and that context provides a specialist interface for your connector. So the way you can think about it is that the OMISs, the Open Metadata Integration Services, each make calls to the Open Metadata Access Services running in the Metadata Access Server. And the reason that we have this wrapping is that one of the responsibilities that the integration service takes away from the integration connector is the need to manage the user ID that's used to work with open metadata and the metadata provenance. So but if we look at these two code interfaces, this is the same method. The top one is the one that will be used by your connector. So here you pass in a set of properties about we're adding a file to the catalog. We pass in a set of properties and an optional connector provider name. So this is used to create the connection object that's associated with the data file. in the catalog. So that's the properties you use. That is calling add data file to catalog in the OMAS. And you can see there are three extra parameters on this call, and these are managed in the integration in the integration service. And that means that where your connectors, that the deployer of your connector gets to choose both whether the what the user ID is, and also what the metadata provenance is for your requests. So that's the reason why you see this sort of pairing of the integration service with the access service. And so now we get to what is the interface of your connector when you write it. So the way to think this, there's sort of two parts to the interface. There's the part that's handled by the base class that integration connectors have. And that's really about getting the connector set up and having all the information passed to it. So there's all connectors have an initialize request, which is used when an instance of the connector is created, and it's used to pass the connection information to the connector. The integration connectors have an audit log. So this audit log will allow you to add log messages to Egeria's audit log from your connector code, and we'll show you how you do that. The connector is given a name, and that comes from the configuration. So all the things that are sort of operational around your connector are all being supplied through these calls as it's being starting up. I'm going to go into a little bit more detail about initialize embedded connectors, but effectively you may, rather than making native calls to the third-party technology, you might actually work with a connector. So for example, you might have an integration connector that's cataloging databases, and rather than having a different integration connector for every type of database, you might have a sort of nested or embedded connector that has a standard interface that can be used for all databases like JDBC. And when your connector started up, it can be given the JDBC connector that it's supposed to be using, and it's unaffected by whether it's talking to SQL Server, Postgres, or whatever. So you've isolated the code to connect to the database from the code to do the cataloging. So that's one of the ways we use embedded connectors, and those are again configured and passed into the integration connector during its startup phase. And then the final thing is to be passed this context object, and that's the object that has the API to open metadata. And so everything in blue here is the same for every integration connector, apart from set context, because each integration service will give its own unique context object in at that point. So that's the only difference, is that the context object would have different methods on it depending on the type of integration service. So that's the things that is done for you. And then once the connector is fully initialized, your start method is called. And so this is the first method that you write, and it's where you process the configuration that you've been given, making sure that it's, you've got all the values that you need. You put out a log message to say you're starting, and then also you can register with listeners with different types of services. So for example, if you want to receive events from the open metadata ecosystem, you register a listener with the out topic, and that's done in the start method. And then every time there's an event, you will get a call on your listener method that you registered at this point, and it will be running in the thread of the listener, and you're able to process the events. So that's the start method. So once you've done all those things, you return, and then the next thing that's called is the refresh method. And the refresh method is called just after start. It's also called periodically, and the period that's used for between the refresh calls is determined by the configuration of the connector. So, so this method is effectively your polling method. Even for connectors that are using events, they still implement the refresh method, although the period between refreshes is generally long, but it's used just as a check and balance to make sure there's been no missed events due to the downtime of the connector itself. So basically, you always write a refresh method. And then you also need a disconnect method, which is called when the server's shutting down or your connector's being shut down. And that's to give you an opportunity to free up any resources that you've been using. So typically every connector will have a start, a refresh, and a disconnect method. The engage method is a special method if your connector needs to use blocking calls. It's configured to do so. And so then the integration daemon will create a new thread for your connector and call the engage method in a loop. It calls engage, waits a second, calls engage, waits a second. And this gives your connector its own thread to do various things on. So you only need the engage method if you are going to do calls that block for a long time, and as I say, you can do whatever you like in it because it's running its own thread. All the other methods are running the integration daemon's main thread, and its job is to step through all of the integration connectors running in it, and when they're starting up, call start, and then calls refresh periodically according to its configuration. So all of those methods are called from the same thread within the integration daemon. All right, so that's a sort of high level design. Let's talk a little bit about the configuration. So the integration daemon you can think of as an array of integration services. The integration service description sort of covers its name and the identifier of the server where the partner OMAS is running. And then it has an array of connector configurations. So that each one of those configures an instance of an integration connector. And in the little blue box that we've got showing at the bottom there, that's the configuration that each individual connector is started with. And so what you've got is a unique identifier for that connector, and that's used when it receives, when it's registering with, for example, the out topic for the OMAS. So if you think of a sort of horizontally scaled environment where you've got 3 instances of the integration daemon, each running the same set of connectors, they would each have the same connector ID. Each copy of the connector would have the same connector ID. So when it connects into the event infrastructure, each event is only processed by one of the instances of the connector. So that's the connector ID. The connector name is used in messages, so it needs a sort of unique, useful name for the operating environment. The user ID is the user ID used when calling the open metadata ecosystem. If it needs a user ID for connecting to the third-party technology, that's stored in the connection object for the connector. So that's the next property. Then the metadata source qualified name is the identifier that's used in when we're doing metadata provenance. So I've talked about this, I've mentioned it about 3 times now, and I haven't gone into any detail, but fundamentally what that's saying is Every piece of metadata in open metadata has what we call a home repository. And this is the repository where that metadata can be updated. And it might be a member of the cohort and that means that any server can send a request to update that metadata directly in the repository that's the home repository. We call that the local cohort metadata provenance. For metadata that is managed in a third-party technology that's not part of the cohort, when we bring that metadata in, so if you think of a relational database that has a schema in it, the structure of that schema is owned by that database. And when we bring it into the open metadata ecosystem, we don't want anybody to change it because it will be wrong. The master copy, the copy that is correct, is the one that's in the database. So what we want to be able to do is to actually record that in the header of the metadata elements that we're storing through this integration connector. And this metadata source qualified name is the qualified name of a software capability that's catalogued in open metadata that represents the third-party technology. So we have a type of metadata element called a database manager, which is a software capability. And so we would have a representative of, we'd have an entity that describes the database, the database manager that is owning the schema. And every element that comes that represents that database schema would be tagged with the qualified name and the unique identifier of the entity that describes the source. And this way we can know exactly where this metadata came from. So that's what we mean by metadata provenance, pinpointing exactly where the ownership of that metadata element comes from. So that's how we set up the value if we're using what we call externally sourced metadata provenance. So we're talking about that one, and then we've got the rate at which the refresh method is called. So if we're doing polling, then you might say, okay, I want this to run every hour, I want this to run every week, I want this to run every minute. We set users blocking calls to true if we want the engage method to be called. Otherwise, by default, it's false, and so engage is never called in that case. And then it's also possible if you have an integration connector that's able to optionally work in two directions, you can switch off a particular direction using the permitted synchronization option. So those are the types of properties that can control the environment around your integration connector. So now I'm going to go into actually looking at some code samples. Now, if you're familiar with our connector framework, there's sort of two parts to a connector. There's the factory class, and this is used when we create a new instance of the connector. And we call this factory class the connector provider. And then you have the implementation of the connector itself. And when it comes to integration connectors, the connector provider, which is shown on the next chart, is pretty much, it's pretty much the same thing that you would expect for any type of connector provider. So what would be different? So if you look at the top of this example, you see that the provider class extends integration connector provider. So that is actually a base class that extends the standard connector provider base class and sets up a number of defaults for the connector provider. But we extend the connector provider, and then there's three parts to it, to the actual implementation, which is the same for all types of connectors, in that the first part you set up the name of the connector implementation itself. The second part, you set up a connector type, and this connector type is retrievable during the configuration process. So the administrator, when they're setting up the configuration for your connector, has to create a connection object, which includes the connector type. And so by having the purpose of the connector type is to describe partly to describe the connector provider. So having the connector provider itself create the connector type it needs to operate reduces the chance of error. So that's why we have our connector providers create and offer the ability to create the connector type for any consuming connection objects. So there's the connector type. And then the final thing is when a new audit log is created for your connector instance, the component description that is added to every log record is sourced from the connector provider. So the setup here allows you to put unique names and statuses into the component description, so that any audit log messages that come from your connector can be uniquely identified as being sourced by your code. So that's why this component description piece is in the connector provider. Now, I've particularly pointed out these recognized configuration properties. And this is where you define the names of any configuration properties that your connector supports. So in this example, we've got two properties here. One of them is the qualified name of a template. So a template is used when we're creating new elements to as a sort of as a template basically. So that not generally what we're pulling in from external third-party technology is technical metadata. The template allows predefined governance and business metadata to be attached to that technical metadata as it's classified. So in this example, this is the property to use in the connection object to set up the template, and I'll show you an example of that in operation a little bit later. And then the other one is it's actually a Boolean property that controls whether when the connector is deleting elements from open metadata, whether it uses a soft delete or it uses an archive request. So that's just basically, so the way to think of these properties are the different ways to control the behavior of your integration connector code. And one of the things with this type of topic, you're probably going, oh, there's lots of detail here. But what you see is that it all builds on it. So I talked about the methods that you implement, and those methods are controlled by the configuration, and we've covered that. And that configuration, along with the function of the connector provider, are used to create the environment for your integration connector. So earlier on, I mentioned the template idea. So here, if you think of Kali's sandbox, the integration connector, all it's got is what the database knows about, which is the schema, the columns, and the tables and the columns. The template would then add the governance metadata. So here we've got zones and owners. Those are being automatically added through the template. So the template says anything that comes from this particular database, set the owner to Kali and set the zone to sandbox zone or whatever zone you're using. So we get the catalog is enriched through the values that are pre-configured in the template. All right, so I mentioned a couple of times that the configuration includes the connection object for the integration connector. And this is the standard structure that you would expect for a connection. So the connection itself is related to the properties that are sort of unique to the consumer the connection object. The connector type, that was the description of the integration connector that was created by the connector provider. So we talked about it creating the connector type. So every time your integration connector is configured, the connector type information, which is used in the creation process of your connector, is used. And then we have an optional endpoint. So this endpoint is describing where the third-party technology is located. But it is optional. So it is possible, if you just had it for your connector, to not have this endpoint explicitly coded in your connection object, but to actually call open metadata to extract the endpoint. And so this would be if you wanted a very dynamic integration connector that was, say, cataloging a range, a sort of whole category of technology. So let me give you an example. If we go back to the integration connector that's cataloging databases, it might be that there's no endpoint for which database to catalog. So what the connector does when it starts up is it issues a query to open metadata to say, tell me all the databases that there are. And maybe it does a little filtering to work out, well, I'm only going to do the Postgres databases. And then it has a list effectively of endpoints to connect to, and it catalogs each one in turn. And then it could listen for new databases being catalogued. And that would be, sorry, let me go on to this next picture. And that would be through a new endpoint being created in open metadata. It would get a notification of that and go, oh, I have a new database and I'm going to connect to it and catalog it. So all the way through open metadata are different places where endpoints are created. So it's possible for your integration connector to be very dynamic. So you might have a CI/CD pipeline that's deploying databases, and each time it deploys a database, it creates a metadata entry for that database. The integration connector is then listening for the creation of the database metadata element. It then goes, new database to catalog, and then goes and connects to it and catalogs the schemas. So that's how you can make these integration connectors very dynamic through the way that the connection and endpoint information is supplied. The next thing you can do, and I mentioned this a little bit earlier, is you can also have embedded connections. So in that case, the connection object is called a virtual connection, and that allows it to have other connection objects embedded within it. So, for example, our open lineage integration connector listens for open lineage events from a Kafka topic. So rather than having logic for managing Kafka embedded in that connector, it uses a Kafka connector to listen for events from Kafka. So it would have a virtual connection. The connector type would be its connector type, so it's factory information. And then embedded inside it, inside the connection object would be connection information for Kafka. So it would only have one of these embedded connections, but that would be the Kafka one. So when it starts up, it would access the supplied embedded connectors, so that's the actual connector itself that will be automatically created for it, pick up the Kafka connector, and then register a listener with it to pick up events from Kafka. So this is a way where you can componentize your integration logic. So, it might be that you're using Kafka as a way of picking up lots of different types of metadata from different types of tools that create Kafka events for their metadata changes. And so by using these embedded connections, you only have to write code to interact with Kafka once, and it can be then used by multiple integration connectors through, as I say, through this virtual connection mechanism. Okay, so let's look at some code. So we talked about the fact that effectively your integration connector has 3 methods that you implement: start, refresh, and disconnect. So here's an example of the start method. And the job of the start method is to get started, really, is the way, oops, gone too far. Gone too far. The job of the start method, as I say, is to get started. So the first thing you always do is that, because you're in a framework, is you call the superclass, and it will initialize various other stuff, headers and things in the connector itself. So it doesn't matter too much what it does, but that's starting the framework above your connector. And then you might say, well, I need to pull the endpoint from my connection. So here you see we're retrieving the endpoint from the connection object, and then pulling out the endpoint address, which in this example tells us the name of the file directory to monitor. So this is from an integration connector that monitors new files being created in a particular directory. So the endpoint gives us the name of the directory to look at. And then the next thing it might do is, if it has configuration properties, here you can see these properties that were created in the connector provider being queried. So was the allow catalog delete configuration property set? Yes, it was. So I'm going to set my own internal flag that says I'm going to issue deletes rather than archives when I'm deleting files from open metadata. And here then you also see the qualified name of the template being brought into a Java variable from the configuration properties, and that will be used later in the
I found this on the web.
Sorry, that was Siri interrupting. So we see the template qualified name will be used later in the refresh request. So so we've managed the configuration. Always, it's a good practice to log the fact that the connector is starting, because then you can look at the console messages and be sure that your connector is actually running. So here we're just logging the fact that the connector name that came from the configuration, the file directory that is being monitored, whether it's going to do deletes, and the template qualified name, if there's one supplied. So there you can verify that the connector started and it's correctly read its configuration. And then the final thing is to start listening. So in this case, it is it's got a monitoring mechanism on the directory. So that's what that code does there, and it will be called every time a new file is created or deleted in the physical directory, and it will react to those changes. So that's your start method done. And here's another start method, and this is by a connector that is listening for open metadata events. So this is a connector that actually is going to be triggered and pick up its endpoints from open metadata. And so the way it registers a listener is through the context. The connector itself implements the listener interface, which means it gets a new method called process event, I think. And so in the start method, it registers itself. So this is with the listener, and it will then be called, its process event method will be called for every inbound event. So that's the sort of 2 styles of start method. Put time, okay. Now we need to implement the refresh method, and you can see here that from this example, this is sort of showing a number of integration connectors working together, and the top half of the picture is showing integration connectors that are pulling information about people and the organization into open metadata, and then at the bottom, so that's this sort of metadata coming inbound into the open metadata ecosystem, and then at the bottom we have metadata going outbound. And so one of the decisions that you make when you're building an integration connector is which direction is the metadata flowing, because we have a slightly different design depending on that direction. So this picture is showing the design of the refresh method for metadata that's coming in from the third-party technology into Egeria. So that's so something like cataloguing databases. And so both styles have what we call two sweeps, so effectively two loops. And in this first case, we start by retrieving each element from the third-party technology and cataloging them into Egeria. You think, well, that's probably all you need to do. But it's also important that we detect things that are deleted. So, for example, say a table's been deleted from the database, we need to remove the representation of that table from open metadata. So sweep 2 is to go through all the elements that are in open metadata and make sure that they are still in the third-party technology, and if not, delete them. So that's the two sweeps when we're bringing metadata into open metadata. And then, but if we're going in the opposite direction, it all swaps around. There's still two sweeps, but we always go to what's the source and step through and catalog all of those elements. And then sweep 2 is to go to all the sort of downstream, the destination technology, and validate that every single one of the elements that are there actually is still available in the source. So that the sort of logical pattern's the same, it's just which system you're talking to is dependent on the direction of flow of the metadata. Now you might say, well, what if we're doing a two-way exchange? And in that case, you have to think about how are you going to know when to delete something from either side. You could say, well, we're just going to accumulate from both sides, or you need to have a way of detecting deletions on either side. So this is easy because there's an obvious sort of master or sort of home metadata collection side and a downstream. But if you're going in both directions, you have to have a think about how you're going to manage that. Okay, so here's an implementation of the refresh method. And here you can see the two sweeps. So this is back to the integration connector that is listening for changes to the files. And it is in sweep 1, it is listing all the files in the directory and cataloging each files. And then in sweep 2, which I couldn't fit on the same page, it's basically going through all of the files that are cataloged in Egeria and archiving those that don't exist on the file system. So two sweeps.
Matt, can I ask a quick question?
You may, of course, yes.
I was just thinking you just said with the two-way system, if you're going both directions, why would that be an issue? Because presumably the only one that can ever be really updated is when the repository owns it, when it's the owning metadata repository. So you would know which repository owned a particular entity. So that would be the one.
So if both are so using the metadata provenance is a way to manage the open metadata side, but with third-party metadata that is not conformant with the open metadata ethos, there's no reason to assume that it maintains provenance information or honors the reference copy. So you actually what you would have to do is completely trust the open metadata as in terms of managing the metadata provenance, but you can't trust that the same rules are supported in the third-party technology. It might be, but it does depend on the third-party technology. Does that make sense?
I think so, because it's not going to be read-only like it would be if it was a.
Yes, that's right. You can't guarantee it's read-only. So it's going to be very specific to the piece of technology, and it becomes important particularly when you're using the catalog integrator, which is designed to be two-way between two catalogs. And I will talk about this in a little while, but it has the ability to capture extra metadata in open metadata to allow you to do this two-way correlation.
So could I just ask if Egeria owned an entity, and would we honour an update then from the integration connection? Because I would have thought we wouldn't have honoured it, or would we?
Yes, that way around, yes, we would. So, for example, because if something's owned by open metadata, it's read writable. If it's owned by the external third-party technology, then and we set it as externally sourced, then it would be read-only, and we would not allow it to be updated in open metadata.
Okay.
But if it's the other way around, which is what I heard,
Yeah.
yes, then of course we can update it in open metadata because open metadata owns it. Did I Did I understand? Or
if it okay, yeah, I think I've got it.
yeah, so basically if it's externally sourced, and the metadata provenance says is externally sourced, no open metadata process can update it except for the integration connector that has the right metadata source qualified name. So, okay, so that's the refresh method. And in the first one, there was a method called catalog file, which is actually doing the cataloging, and the code in there, again, it didn't fit on the screen, so that's why it's broken up, it has two options, two ways of working. So one where there's no template. Oops, what did I do there? Oh, sorry about that. One where there's no template, which is this first one, so it's literally for each file, it's filling in the properties, and then making a call to add data file to catalog. And it's not providing a connector provider name, so that means that the internal would default to the connector provider name for the type of data file that's being created. And then the else, which is currently collapsed in this picture, is where the template qualified name is not null. So if the template hasn't been looked up, if this is the first time through, we actually look up the template and get very upset if it's not there. But assuming it is, we then use the template GUID to set up. So in this case, I don't know if you can see my cursor, but we're calling add data file to catalog from template, and we pass the GUID and the properties that will override the GUID there. So that's there's basically the two choices between not using a template and using a template. So apart from the extra work to actually get the GUID of the template, it's simple to use it with a template as without. And from a style point of view, the reason that we don't get the administrator to configure the GUID rather than the qualified name is that GUIDs are very easy to misspell. They're not very human friendly. So by using the qualified name, there's a better chance that the administrator will get the value right and can validate that value is right than using the GUID. So GUIDs are great for systems to look up. Qualified names are more human friendly. Okay, so final method, disconnect, is basically, this is just the shutdown. So here we've stopped directory monitoring. We've put out a message to say we're stopping, always useful, and we're calling the disconnect method of the superclass, which will clear everything that's being managed above your integration connector. So those are the three methods: start, manage your configuration, register with your listeners, refresh, which is that sort of continuous polling mechanism, doing the two sweeps, and the disconnect method, which is the shutdown, cleanup, and end method. So I think all I've got really is a couple of extra bits to go, looking at the time. So the first is I wanted to talk about the metadata provenance, and I've referred to this a number of times. And as I say, what that does is when we switch it on, everything that's being created by your integration connector will be locked as read-only in the open metadata ecosystem. And this little table here shows you the different mechanisms and the approaches to metadata provenance with each of them. And it's as I say, it might be a toggle switch. So you say everything is going to use external source or is not. For things that are more sophisticated, so like the catalog integrator, you set it on every method. So you can do a mixture. And for like the files one, well, we assume files will always be local cohort because there's lots of different systems have access to files, so no one really owns a file. I think that's the main different type. So they're basically different styles of setting it. The lineage integrator is slightly special in that it also has listeners that are managed by the context manager. And this is because we support inbound open lineage events. And so it's possible for an integration connector to listen not only for inbound events from open metadata, but it can also listen for inbound events from open lineage and also open lineage events that are being created by other integration connectors. So this one is slightly more sophisticated in terms of where you can get events from, but everything else is exactly the same. And then here's just showing the different listeners that you can register, and also you can publish events. So that's really, and those two, this top group of three are the ones that are managed by the context manager, and then the bottom one, the standard register listener, is registering with the open metadata ecosystem. So that one's a little more sophisticated in that respect. And then the catalog integrator, because it's working between catalogs that might have complex relationships, and also lineage, because we're pulling from lineage information from different technologies. There's an assumption that the mapping between open metadata types and the third-party metadata may not be one-to-one. And so we have support for something called external identifiers that allows that mapping, whether it's one-to-many or many-to-one, to be stored in open metadata. So this is how we can increase our ability to correlate between complex structures, externally managed and open metadata. And so this is the sort of, so here, this is the API from the catalog integrator, again, creating a data asset similar to the previous one, but you see there's a whole load of extra information that you can supply to help with the correlation process with that external element. And finally, you do need to test your connector. So the way that you build your connector as a separate jar file, so the connector implementation and the connector provider implementation are stored together in a single jar file. And then that jar file is installed in the lib directory of your platform. And then you can go through the standard configuration process of creating a metadata access store and an integration daemon on your platform with your connector configured, and then you can run your test cases and make sure that the connector is running. Okay, that's it. Lot to cover, but I hope this has given you a bit of background on how to write an integration connector. And if anybody's got any questions before we finish.
No question from my side, just a comment that this was quite useful for me.
Thank you.
Thanks.
Okay, so as David said at the beginning, the next webinar is with Chris Grote, and we're going to talk about a different type of connector called the repository connector. And this allows a third-party metadata repository to actually connect directly into the cohort. So that should be a very good topic. Other than that, thank you very much for attending.
Thank you, Mandy.
Thank you. Cheers all.
Thank you, Mandy.
You're welcome.